Hi everyone! Okay, so I posted for you guys today an assignment on area of triangles and parallelograms. And I know it's going to be a little bit tricky because it is a little bit longer and I know that can be intimidating, but I can assure you what just happened. Pause. Sorry, I pressed a button and something weird happened, so I paused you real quick. You didn't even notice. Okay, anyways, um, so area of triangles and parallelograms, so what we're working on right now. And yesterday's work had you looking at areas of polygons and weird shape things, and you should have found at the end that the equation for the area of a triangle is half the length times the width, or half the base times the height. And we know that base times height is the area of any four-sided figure. So if I just was to come over here real quick, and I just wanted to draw a quick little four-sided figure for you, I know that the area inside this shape is going to be this dimension times this dimension. We can call this the length, we can call this the width. This book calls this base and calls this the height. Totally reasonable stuff. So we know that base times height or length times width gives me the area of this, but a triangle is half of that. So if I do half the length times the width, I'll get the area of the triangle in here. So I'm just gonna pause real quick and erase everything, and we're back. So we're gonna talk about area of triangles and parallelograms. We know the area of a triangle, half the length times the width, or half the base times the height. Parallelograms are going to be a little interesting though because they're oddly shaped. So we're going to start here. I'm just going to help you through some of these, give you a little bit of ideas to get you thinking. Cam's going to come over and say hi. Hi, Cam. Sorry, can't break it. Okay, so I'm just going to help you through these a little bit, kind of get you thinking, but I'm not going to do all of them for you, just going to give you some ideas. Okay, so the first one, read the problem below, then explore how to find the area of a figure by breaking it up into triangles and parallelograms. A part of another stained glass window design is shown below. How much glass would you need for this part of the window? So we need to find the area inside all of this. So they're suggesting we break it up into different parts. They're looking at breaking it up in half this way. Interesting tactic. I think what I would have done is chopped off the triangular ends here, find the area inside that, and then if I chop this off and take this part of the triangle and put it over here, you can make a parallelogram. But let's follow what they think. Let's see what they have to say. So you can draw one of the parallelograms and one of the triangles and label them with their dimensions. So we have the dimensions here. You just count the bricks here. So they drew a parallelogram and did the dimensions. Notice the height here. Notice that the height is from the top of this shape to the bottom, but not on the diagonal. It's really, really important to remember that the height here is never a diagonal side. It's always perpendicular to the base. Perpendicular means that it creates a 90-degree angle. Creates a 90-degree angle right in there. And that means that at my 90-degree angle, I know the exact height. So from base to height. So you have to look for that 90-degree perpendicular line that goes straight up. That's your height. Don't pay attention to diagonals. And then they said you can use the formulas to solve. So parallelograms, just like any four-sided shape, is base times height. So here, the area of this one would be 12 times 3. 36. 36. And the area of a triangle is half that. So 10 times 3, 30. Half of 30. 15. Okay. So that's all you have to do on the first one. Nothing has to get written down on that one. Just some thinking. Okay. This is where you're writing it down. Now you use your drawings and formulas for the area of triangle and parallelogram to solve the problems on the previous page. Look at the picture it, which is right here. How can you find total area of the figure? Break it into parts. And that's a perfectly perfect answer right there. Break it into parts. Break it into parts that you feel comfortable measuring. For me, the parts that I would have broken it into, I would have chopped a line right down here and right down here. That creates a rectangle, 2 triangles here, and I can chop this into 2 triangles, stick them on either end of each other, make a parallelogram, just do base times height. That would have been what I would have done. They created trapezoids. I bet they're going to chop this part of the trapezoid off here and stick it on over there. So just from this one, you can just do base times height here, and that will also find it for you. What can you say about the 4 parallelograms? So the 4 parallelograms that are being created here is this purple one from the outside of the green line here, this other purple one from the outside of the green line here, this purple one, and this purple one. So the green line is creating the boundaries, and the 2 triangles they're talking about is the 2 green triangles. So what can you say about the 4 parallelograms? Well, if these measurements are correct, which I think they are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are correct. I already helped you on this a lot more than I thought I would. What can you say about them? Well, we know their dimensions. We can look right there and we can see their dimensions. So I have a pretty good idea of what I can already determine from them. I know to find the area of the 4 parallelograms, base times height, and the 2 triangles, half of the base times height. Area of the parallelograms we already did. Area of the triangles we already did. Calculate the amount of glass needed for the window. Add them together. Explain how you can find the area of a polygon. What did we do? How did we make it easier for ourselves? Think about some of the strategies that we talk about when we try to make things easier for ourselves. And then you're going to apply that by doing this. Okay? I want to see the math that you do here. If you draw it on a separate piece of paper, take a picture, and add it, that's perfectly fine. But if you can just tell me the calculations that you're doing, that'd be another perfect way to show me how you would find the area of these 2 shapes. Remember, parallelograms, base times height. The height here is this vertical line that they gave you, never the diagonal. Triangles, half the base times the height. The base here is 6. The height, see how they drew this extra shape here to show you that height? That's because it has to be perpendicular. It has to be a vertical line, not a diagonal line. That is going to be 3.5. Okay, that's the first part done. Second part, trapezoids. In art class, Swati created a trapezoid made up of smaller trapezoids that are all same size and shape. If the height of the large trapezoid is 4 inches and the base measures 5 inches and 10 inches, 2 bases. Each of these is considered a base. What is the area of the large trapezoid? What is the area of one of the small trapezoids? So you can draw the large trapezoid and label it. So I'm going to do that over here. Now this is not going to be that great because I'm trying to draw with a mouse. Sorry. Nope. Oif. Well, effort was made. You can draw a large trapezoid and label it. So let's label it. We know down here is 10. We know this is 5. And then the height was 4? 4. And I'm going to use black here to show that this is 4. Okay. You can separate the trapezoid into 2 triangles and 1 rectangle. Oh, okay. Okay, so let's do that. Let's draw another line to separate it to two triangles and one rectangle. So we know that this length is also going to be 4. How about down here? Well, if the top here was 5, this length from this and this also is going to be 5. Okay, well, if the entire length was 10, and we know this part of it is 5, how much is left? Well, 10 minus 5 is 5. There's 5 left over, and the 5 left over has to be split up between this triangle and this triangle. So I'm going to have to divide it in half. And divide it by 2. And 5 cut into 2, think about like 50 cents cut into half. It's going to be 25 cents or 2.5. So I know this side is going to be 2.5 and this side is going to be 2.5. Notice that I don't care about the diagonals. I really don't. So who cares about this? Who cares about this? Doesn't help me. And now we can find the area of the rectangle and the triangles. So inside here is a 4 by 5. This is 2.5 by 4. So 5 by 4. And I know 1/4 times 4 is 100 with 1 decimal point, so that's 10. But I have to cut it in half because remember, it's half. But also, I have 2 of them. So cutting it in half and then doubling it, it undoes each other. So I know that this and this, these two triangles together, is going to be 10. So this is 5, this is 5. I'll write it in here, 5 and 5. So I know the area in here is going to be 20 plus 5 and 5, which is 10. So the area of this entire trapezoid is 30. Well, I'm noticing that I'm running a little over time on here and I didn't want to spend this much time on it, so I apologize. But I trust that you guys are going to be able to answer all these questions because I kind of just did for you. You don't have to draw this if you don't want to, but you can. Just writing down the answers is perfectly fine. And then do the same thing over here. Pay very careful. If this is 3 and this is 4, you know that this line here is not straight. So this is a very skinny triangle. Careful. Okay, if you have any questions, please let me know. Email me, or I can set up a Google Meet. We can talk and I can walk through you that way. But try your best. Don't give up. I know it can be tricky, but you've got a few days to get this done. And I believe in you. You can do it. Okay, bye guys.